Welcome. My name's John Tarascus. I'm one of the moderators for Stormwater Awareness Week. We'll be starting in just about a minute here on a presentation on erosion control products by the Erosion Control Technology Council. So welcome everyone. And we'll get started in just about a minute. All right, well, it's 8 o'clock and we want to give these folks as much time as possible. I have been looking forward to this workshop. When I heard that the Erosion Control Technology Council was presenting, I was so excited because erosion's kind of my thing. I enjoy erosion and studying erosion, teaching about erosion, and helping people control erosion in the field. So I'm looking forward to this group. I want to introduce you to Mike Jotsky with the Erosion Control Technology. He's got a team of presenters, and so Mike, I want to give you as much time as possible. So let me spotlight you for everyone and go ahead and introduce your team.
Yeah, perfect. Well, good morning. Yeah, so just excited to do this presentation with you guys today. It's kind of a condensed presentation. We usually do this in more like an hour and a half to 2 hours, but we're going to condense it in and try to get as much information to you guys as possible. But feel free to reach out to us, and we can do a direct meeting for you guys at some point if you desire. So again, I'm Mike Jotsky. I'm the technical chair for the ECTC, or the Erosion Control Technology Council. I also work for Western Green as their technical manager. I'm located in Greenville, South Carolina. Diane Smith is our executive director. She unfortunately couldn't make it today. She was going to, but had some complications with travel and can't make it. And I'll turn it over to the other three to introduce themselves.
Hi, everybody. My name is Craig Schultz. I'm the business development manager at American Excelsior. I run our training and testing facility in Rice Lake, Wisconsin, called the Erosion Lab. So I'm glad you've made some time to listen to our presentation today. Thank you.
My name is Brian Foster. I'm with LSC Environmental Products. I'm based out of California, and I'll be talking about the hydraulic erosion control products during our presentation.
Good morning. My name is Keith Potter. I'm with Silt Saver outside of Atlanta in Covington, Georgia, and I'll be talking specifically about performance-based sediment control products.
All right, so we're going to do kind of a general overview of who the ECTC is, and then get into specifics on road erosion control products, turf reinforcement, transition mats, hydraulic products, and then sediment control devices. And then if we have a few extra minutes, we'll do fasteners and anchors. So who is the ECTC? So we are a nonprofit organization made up of companies that specialize in erosion and sediment control products. Since the inception, the mission has been to promote education, standardization, and innovation in the industry. We focus on advanced erosion and sediment control technologies through science-based testing and driving the industry standards forward. So we primarily serve almost every organization, anyone that has anything to do with erosion and sediment control, which includes project site owners, engineers, regulators, landowners, homeowners, really anyone that is dealing with a project site that has some kind of erosion on it, which is pretty much every single site. So our main focus, though, is to provide clear specifications, CAD details, installation instructions. We do that through details as well as videos. And then we also do training events and white papers to educate people about the technologies and the new technologies that are coming into existence. So our membership's kind of made up of a wide variety of different groups. Most of them are manufacturers of either erosion or sediment control devices, but there's also lots of other groups in there too. We have different raw good manufacturers that we utilize. We also have labs and testing authorities, as well as universities and consultants that are part of the group too. So it's a really diverse membership, but our goal is to make aware what is going on in the erosion world. So what is erosion? Simply, it's just the migration of sediment from one place to the other. Usually it's going to happen with water. Could also happen with wind, frost, or there can be mechanical applications like mud getting stuck to your tire and driving down the road. So we deal with all of these on a day-to-day basis, but this presentation is going to mainly focus on the water aspect of it, as that's the one that causes the most erosion. So that process is simply the rainfall starts. That rainfall actually creates a lot of damage to that soil because it dislodges that soil if it's not protected and will cause those little particles to start moving. Then you move into sheet flow as that water starts to accumulate and run over a surface area. And then that will create rills, those little small rills you see on many construction sites, which over time, if not taken care of, will create bigger gullies. But why do we really care about that? I mean, there's two main reasons. There's, of course, the economical impacts, but then there's really more important, the environmental impacts. So, environmentally, sediment leaves the site, you're losing nutrients and plantable area. So you're going to have to rebuild that, put nutrients back in. But of course, then that soil moves off site. So then you're going to have to deal with that. If it's in the waterway or anywhere, you're going to have to clean it up. So because of that, it creates a big financial impact, which causes the U.S. I mean, this is not just the U.S. problem, it's everywhere. But we spend lots and lots of money trying to clean it up. $13 billion annually just to kind of take care of pollutants, not to mention all kinds of other issues. But we did do a cost-benefit analysis on how well sediment erosion control devices work. And the study found that for every dollar spent on erosion or sediment control devices, we would see a cost savings of over $5 to the end user. So definitely worthwhile to invest in using these products. We also do work with federal regulation. Of course, we get information from the EPA. We also share information with them to kind of create best management practices and just make the best systems possible. So there's three different kind of classifications on protecting for erosion control. So you have your typical hard armor systems, which was the what used to be used a lot, concrete, riprap, hard armor systems. Now these systems do work, but they're not necessarily always environmentally friendly. So what we mainly focus on is soft armoring system or revegetation systems. So the soft armoring systems are going to reinforce vegetation, help them to be stronger so that they can withstand that higher flow rate. And then of course, revegetation, adding other things in there to help that vegetation grow, because vegetation can handle a lot of flow by itself. So we'll get into the more specifics about these later in today's conversation. And then we also have to talk about sediment devices. So erosion devices are going to stabilize that slope or that channel and keep sediment from moving. But that's usually post-construction. Sometimes you're doing it with construction, but during construction, you're actively working on that site and you can't put a blanket down or you can't get vegetation to grow because you're working there. So you need to create a perimeter or a check dam or something to keep that sediment on site. So that's where sediment control devices come in, which will be another section. And then we do also, since we are a technology council, we do rely heavily on testing labs, third-party testing labs. There's two that we mainly work with. We work with TRI Environmental in South Carolina, and then TTI, which is in Texas, Texas Transportation Lab. And so they're doing actual large-scale testing. They're actually running channels in a flume, doing rainfall simulation to make sure that we understand how these products work and how to design with them. And then, as I mentioned, we do have installation instruction on all these, and it is important because if you don't install them correctly, then a lot of times we will see failures. So definitely follow the guidelines that are provided either by the manufacturers or by us. But you need to look at that and decide, what's the proper product, what's the proper application rate, and how to install that. And we do have, again, those videos on YouTube. And then one note about specifications. So we do have all these specifications listed on our website, as you can see here. But there's two different categories of properties. We have index properties and performance properties. Index properties are properties that kind of describe the material. They're going to be like thickness or mass. And these properties are really used as a quality control measure. So they'll tell you if that product is being consistently manufactured and if it's that product you ordered. But you can get a product, you can have two products that have very different index properties, but still perform the same way. So we really can't always define or compare products by index properties, but we can compare them by performance properties. And those are the ones you do need to focus on when you're designing, such things like velocity, shear force, tensile strength sometimes, that you need to look at and decide if those are the ones that are more important on designing a product and making sure that they fit your parameters. So I'm going to turn it over to Craig. He's going to introduce us to RECPs.
Hi, thanks, Mike. Hi, everybody. Good, we got the slide up. Hey, I want to spend a little bit of time today. As Mike said, the presentation day, we normally spread out over a little bit longer. So we're going to highlight some things here, but we're here to answer your questions in the future as well. Just wanted to touch on temporary rolled erosion control products, often called RECPs. So RECPs play an essential role in both temporary and long-term erosion control strategies. Erosion control blankets have dual functionality. First, they provide that immediate erosion control by shielding the soil surface, reducing the impact of raindrops, slowing down runoff, and preventing the soil from being washed away or blown away in some instances. Secondly, they're there to create this favorable environment that's needed for vegetation to establish by retaining the moisture and providing protection from harsh weather conditions. Next slide, Mike. Thanks. So where can they be used? I can control. Sorry, Mike, I just saw that. Thank you. I apologize. So where can RECPs, be used? Just about anywhere. I mean, I'm sure if you're on this call, you've probably seen them used in a lot of different places to control erosion and encourage vegetation. As with any best management results, best management practices, we recommend that you look into all the things that are going to impact the performance, right, or the success of your project. Soil type. Soil type's a big deal. What do you need? What don't you need? What sort of extra protection or soil amendments or whatever should you be using to encourage the vegetation? What's the steepness of the slope or the channel? Very steep slopes may require some different sorts of protection. You may have to establish your vegetation more quickly or put in a crop, a nurse crop or something like that. The type of the flow scenario in a channel. Under concentrated flows, some of these products are designed to work in more concentrated flows than others and to protect in certain conditions. Maybe we need to jump up to what we're going to talk about in the next section, which are turf reinforcement mats. Talk about anchoring. This is an important part of any best management practice that uses anchors. The anchor frequency, the anchor type, how loose is the soil, how deep do we need to go, and those sorts of things. And the desired service life. You'll see that temporary rolled erosion control products may last anywhere from 3 months to over 3 years. So what needs to be done to protect the vegetation and to get it established? And, vegetation variety, as I mentioned earlier, what germination requirements are there? Do we have a nurse crop? Do we have an annual? Do we have a perennial? Do we have lots of natives? What are we working with? But these blankets can work in all these different situations. So as far as the matrix types, as we talk about the most common matrix types used in rolled erosion control products, they're really broken down into these categories. There's straw, there's coconut, and a blend of those two, Excelsior fibers, which is wood, and then we also have a category for open weave textiles. So straw fiber. So straw is an agricultural byproduct. There's lots of straw blankets on the market. It's pretty cost effective. Like I said, lots of different people make it. They're good at providing an immediate cover and typically used in less severe erosion control scenarios and in flatter slopes where expected vegetation establishment is relatively quick. Then when you get into the blends of a straw and coconut, you're going to take the benefits of both of those. Again, natural fibers. In most cases, you'll see those in a 70-30 blend, 70% straw, 30% coconut, able again to extend your longevities a little bit with the coconut fiber, but still primarily straw. Coconut is considered one of the longest lasting fibers that are used. Again, functional longevity of up to and maybe a little more than 3 years. These are fibers that are imported to the US, but they do have their application, and there are 100% coconut blankets as well. Excelsior fibers, these are man-made machine fibers that are made from wood. They're cut to a certain width and length to get the fibers that the manufacturer would like to have. These, sometimes you may have heard of wood wool or wood excelsior. Those are other terms used for excelsior fibers. They can be can create blankets that have functional longevities from 3 to 6 months up to over 3 years, depending on the mass per unit area they use. And so forth. And then lastly, we have open weave, what we call open weave textiles. You'll often see OWTs. These are also natural products, woven mesh mats, longevities of up to 3 years. And again, lots of different configurations of those. We put one up there, but they're often considered a textile because of the way they're manufactured. Netting. So we've seen a big move in the industry to go to some of natural netting, but there are some netting types used. Most erosion control blankets do use netting. There are some netless blankets on the market as well. The type of netting that's chosen can significantly impact the performance, the longevity, and the environmental footprint of the blanket. There are 4 primary types. There's natural, you see there, biodegradable, typically a jute scrim, completely biodegradable, 3 to 12 months in longevity. These nets generally have a woven design, so they're not fixed joints. Then you also have a rapidly degradable synthetic netting, which is made of synthetic materials and is designed to degrade very quickly, usually within a few months. This type of netting is used primarily in temporary situations where vegetation is going to establish very quickly. Then we have regular degradable synthetic netting. This also is synthetic materials, obviously, but it's designed to last a little bit longer, typically 12 to 24 months. It's used in scenarios where a longer period of erosion control is needed before you're going to have full vegetation establishment to give you that little extra protection. And then lastly, the UV stabilized netting. Now this material is treated to resist degradation from sunlight. And this netting can last several years, providing that longer protection if you need that for situations where your vegetation is going to take longer to establish and more robust strength is needed. We talked about biodegradable, and that has been one of the biggest growing areas. But regardless of the netting, you need to look at your application just like you do on the fibers. What do I need? What's the expectations? What's it meant to withstand? Installation. Well, everybody will bring up installation, right? Everybody's going to talk about how important it is with any rolled erosion control product, and proper installation is huge when it comes to any sort of BMP, and blankets are no different. The specifics may vary depending on the type of blanket and the application, whether it's a channel or a slope. But generally, you're going to talk about all the things that make sense, right? We're going to talk about our site preparation, prepare the site, removing the rocks and the sticks and all that thing, all those things to help ensure that the blanket has good soil contact, that the seeds have a good place to grow. We're going to pick the right vegetation, as I said. Are you using a lot of natives? If so, are you going to put down a cover crop as your best management practice, going to support and protect the environment long enough, protect the seabed long enough? Roll alignment. When you're dealing with rolled erosion control products, especially in channels, you will always have an overlap of the seams to provide that good protection under those flow conditions. And with some products, you will also have an overlap on the slopes to make sure that you have no openings. Some products on slopes don't require overlap, but every product that I'm aware of requires overlap in channels. Securing the blanket, I mentioned that earlier. What type of anchors do we need? How loose is the soil? Do we need a straight type of anchor, a twist pin? What do we need? How deep does it need to go? What are those conditions? And then putting them in the proper location and frequency, putting them at channel changes. What type of trenching do we need at the top of a slope, for example, or the beginning of a channel? We need to trench in those blankets. At the top of a slope, if we can't go more than 3 feet over the crest of a slope, we generally want to put a trench in. Those are all really, really important installation characteristics. And then those final checks, walking the site, making sure that everything's anchored where and how it should be anchored. Because of time today, we don't go into a lot of specification work. As Mike explained, there's a lot of information on our website, but generally speaking, the Erosion Control Technology Council specifications for temporary RECPs outline the considerations for their selection, their installation, and performance evaluation. This guiding document is for all manufacturers and contractors and designers involved in the use of these products. We set out criteria for the composition of the product first. The temporary, as I said, are made from different net materials, both the fibers and the netting. We talk about the physical properties that these possess, whether the mass per unit area, thickness, tensile strength, etc. The specification also provides guidance on the appropriate applications, where you might want to consider using these temporary RECPs, things like slope, flow, shear stress, and those kinds of things, and then help you find those correct installation procedures. So while we don't go into a lot of that today, there is a lot of good information on the website for these specifications, and I encourage you to go take a look. All right, I'll pass it over. Thanks, everybody.
Yeah, so turf reinforcement mat. So turf reinforcement mat is just another type of RECP. Although it's a long-term application. So anything that is the technical definition, if it lasts longer than 36 months, it's considered a permanent turf reinforcement mat, or TRM. So they're going to be made of synthetic materials, but still pretty much do almost the same thing as an erosion control product does as far as protecting the slope. But it's going to work with that vegetation, strengthen it so that it can handle that higher flow rate that it is experiencing. So applications where we see turf reinforcement mats, usually going to be channels or steep slopes. Can be other ones too, but typically that's where we're seeing them. So things to consider, is what type of soil are you going to be able to get vegetation to grow? How much vegetation can you grow? Those kind of things we got to ask to decide which product is going to be best to use. And there's products that can use for all of those, but we do need to ask those questions up front. So the top three pictures there are a channel that we were able to convert from. Well, actually, the riprap had failed, and we had started getting too much erosion in that project there. So they removed the rest of that concrete, regraded the site, put down the turf reinforcement mat. This one actually had a degradable matrix in it, so that it would help the vegetation establish a little bit quicker and have less synthetic material there. But you can see it vegetated quickly, but with that mat, it was able to withstand that shear force and that velocity of that water coming out of that pipe to stabilize that site. Slopes too are important. As we get water running off, especially long, steeper slopes, that water gets really fast as it moves down that slope. So you may be stable at the first half of it, but then it picks up so much speed that you're going to lose soil at the end of it. That's where we're going to use a turf reinforcement mat as well. Three different main types of turf reinforcement mats. We have stitch bonded mats, which are, so you have a couple, either 2 or 3 synthetic nets, and then you have a matrix inside of that net, and it's all stitched together. That matrix can either be degradable or synthetic. So we could do a coconut or a straw inside of there and have that natural component, which works on a lot of applications. But there's sometimes where we know we're not going to get full vegetation stand, such an arid environment, or just in a condition where it's always wet and you can't get vegetation to grow. That's when we're going to use that synthetic material. Melt bonded fiber, these are strands that are heated and melted together to create that connection as opposed to stitching together. These are usually a little bit more open in their construction, but what we do is we blow a hydraulic mulch or some other material into that to help that vegetation to grow. But again, it's to create that area where the vegetation can interact with that synthetic material and create a stronger system. And then we have woven TRMs. So woven TRMs are considered high performance turf reinforcement mats. So they are going to have a tensile strength higher than 3,000 PSI or pounds per square inch. So they act more as like a grid in a lot of ways, but still protecting against erosion control. So these are going to get used on areas like spillways, levees, dams, really high flow concentrated areas. Um, so, and then also can be used for structural applications, slope stabilization areas. Now, with all of these, vegetation is crucial. In the name, turf reinforcement mat, it's made to reinforce that turf, either that root zone and that stem zone. So, you think about on a site, you have, a couple blades of grass, they're kind of individual. The root structure will hold them together some, but, water running over that can easily pull out those roots. But if we introduce that turf reinforcement mat, those roots and those strands of grass get intertwined in there and create a stronger system. And that's how it works. So we do usually want to use these with some type of vegetation. Again, it can be used without, but your performance values are going to change a little bit. But we can get vegetation established almost any way. We can do it with seed underneath, seed on top, or we can put turf on top of it, or sod on top of it and let it grow through. We can soil fill these and let it grow through that way as well. Really, it comes down to what is the best for this site? What's going to create vegetation to grow the quickest? That's the method we're going to pick. There's not really one better than the other. On paper, it's what's best for your site. And it is important. It doesn't have to just be turf grasses. It can be natives, which we do encourage natives to be used, as it's going to create a better system in the long run with less maintenance. And you can also do plugs through these. You can do trees, pots, almost any type of planting you can do in conjunction with these to create the options that you want. Installation is going to be identical, really pretty much to RECPs, just making sure it's trenched in, you're not getting water underneath that system. And a quick note on specifications. There's basically 5 different categories for standard TRMs and then 1 for high performance turf reinforcement mats. But you can find all that information on our website. So what happens once you hit that design performance level of a turf reinforcement mat? But before, you used to just have to go then to a concrete hard system usually. But now in the marketplace, we have some transition mats. There's multiple different systems here that will help you get past that. So a turf reinforcement mat can get you to about 25 feet per second, maybe 30 depending on the application. But transition mats will get you to that next higher step of flow rate. So these top 2 pictures are the same project, right at a pipe outlet. So we have really turbulent water flow as it was exiting that pipe. We needed to slow it down, and instead of using riprap, we put in this transition mat. And you can see, nice and green. So the benefit of using this is that you're still going to get vegetation grow through it, still going to get infiltration, as opposed to a harder system. And usually a lot less maintenance and a long-term durability with this type of system as well. But you can use it anywhere, mostly used at pipe outlets, but then you can also use it at curb cuts. Really anywhere you have a really concentrated water flow, that's where these systems really come in to play. Installation of these, you do need to still put a turf reinforcement mat underneath of that product, and then the transition mat on top of it. Still going to want to get vegetation to grow through it. General guidelines on sizing of that mat. Now that can vary, of course, but there are calculators out there and available to help figure out what is the best there. We currently don't have a specification. We're working on it in conjunction with ASTM right now to create one that's usable, but we can guide you through that process if you want. And then we move on to hydraulic mulches.
And that would be my part. Hi, I'm Brian Foster. I'm with LSC Environmental Products. We're going to talk about hydraulic erosion control products. Its acronym is HECP, one of our many that's used in our field. HECPs are a mix of mulch, a type of mulch that are mixed with water and sprayed onto soil. The primary purpose is to control erosion and establish vegetation. These products typically consist of mulch components like wood fiber, cellulose, recycled newsprint, straw, cotton, or other organic plant materials. A common feature in HECPs is the inclusion of tackifiers or polymers, which can enhance the adhesion of the slurry of the soil to bond to the fibers. When you hear the term bonded fiber matrix, it refers to this bonding process facilitated by the tackifiers. Sometimes tackifiers are included in the hydromulch bale, but they also can be mixed in field and in the hydroseeder. You might, we're going to differentiate what hydromulching and hydroseeding is. So the difference is that hydroseeding involves the inclusion of seed and soil amendments, while hydromulching does not. I'm in Southern California, and here, for example, our rainy season is very limited, and very often we use hydromulching solely for the purpose of soil stabilization without aiming for immediate vegetative growth. This approach prevents erosion until conditions are ready for construction or more favorable planting season is upon us. Hydroseeding, on the other hand, combines seed, mulch, water, and a slurry that promotes rapid vegetation and growth. It's a highly effective for erosion control and establishing vegetation rapidly and over various landscapes. The slurry is applied using a specifically designed tank, or what's called a hydroseeder. It's typically mounted on a truck or a trailer, and often includes the tackifier to help the mixture adhere to the slopes. So there's some advantages on HECPs or hydroseeding. Hydroseeding excels in covering large areas, hard to reach areas very quickly and uniformly, even on steep and rough terrain. This mulch is in a slurry helps keep seed in place, retains moisture, and creates a beneficial microclimate for seed germination. Additionally, the slurry can be customized to suit the site-specific conditions and desired vegetation types, such as grasses, legumes, wildflowers, or shrubs, depending on what your desired vegetation desires are. Again, tackifiers play a crucial role in this erosion control practice by ensuring the mulch and seed adhere to the soil surface, reducing washout from rain and wind. While some slurries may include soil amendments or fertilizer to enhance growth, it's important to note that the hydromulch itself does not contain the seeds. The seeds are typically applied separately or mixed into the tank and hydroseeding process. The application machines are called hydroseeders, and they can vary in size, but typically range in size from 1,200 gallons to 4,000 gallons. Larger machines are quite powerful and allow them to spray from significant distances, making them suitable for inaccessible and rugged areas. It's important to note that the green color in hydromulch is simply a dye and is used for visibility and does not affect the growth of the vegetation. This simply shows the applicator what areas have been covered and how much product has been laid down. This dye typically fades within a couple of weeks. And I did see that Mel G asked about malachite green as a toxic. Most hydromulches typically use a dye and can include malachite green. Some do, some don't. It's found that it's used in such a small ratio over many acres that it's found to be non-toxic because it's diluted in to a minuscule amount. But the only state in the nation that has outlawed or disallowed malachite green is the state of Minnesota. And so there are some products in hydromulches that still utilize the malachite green product. Once grading of a construction project is complete, the disturbed land can be highly vulnerable to erosion. So HEPs are an excellent solution in such cases, providing immediate coverage and promoting vegetative growth. People most likely to see hydroseeding on roadways or highways. Many DOTs and other agencies use this practice to stabilize vegetative roadside slopes and right-of-ways. So it's great for slope and embankments because you can quickly cover those areas, minimizing traffic closure and dangerous situations with people being out on the road. So again, roadside and highway projects typically use hydroseeding. And here in California, we get used a lot on wildfire recovery areas. After a wildfire has burnt, the soil is very susceptible to erosion. So oftentimes they will cover the ash and silt created by the wildfire to cover that area with a hydromulch and keep all that silt and ash in place. Another large area that HECPs use are for pipeline or other linear projects, and so you can cover quite a big area in a short amount of time via hydroseeder. And both in pipeline and in burned areas, oftentimes we can incorporate the use of aircraft, be it a fixed wing airplane or a helicopter, to drop mulches out of a aircraft. So in ECTC, we kind of categorize HECPs into 5 types, and they can go from what we call base mulches all the way to highly engineered performance mulches. So on the far left, you'll have a base mulch. Again, most typically, it's a 100% wood defiberized into a mulch bag and mixed with water. And then we have type 2, the second, which is typically a blend of either 70% wood, 30% paper, or some various type of that, but might include a little bit of tackifier. Tackifier is at 1 or 2% of a ratio from tackifier to mulch is kind of what we find type 2 in. Type 3 increases the tackifier application or ratio, typically at a 3 or 4% ratio of tackifier to mulch, and that would be in our what we call a type 3. And then you step into type 4s and 5, and that's when you get into the higher performing erosion control products. What we would probably put what's called a bonded fiber matrix in a type 4. These are prepackaged with a high level of tackifier included, some cross-linking agents, typically polymers maybe, and various engineered performance products that are meant to be longer lasting, higher performing for steep slopes. And then type 5 is where we really have high performance products that are engineered, typically all mixed into the bale, products that can last 12 months or longer on steep slopes, 1-to-1s, and are typically applied at 3,000 to 4,000 pounds per acre. So as in all BMP installations, slope and soil preparation is important. But unlike RECPs, where smooth surface is recommended, so for blankets, you want a smooth surface because you want intimate blanket to soil contact to happen. HECPs typically recommend a roughened surface. So track walking slopes, as you see in this picture here, that create a little caveats in the slope surface are recommended for hydraulically applied products. It's found that by track walking slopes, even if no other BMP is installed, that can reduce erosion up to 40%. So remember, in a rolled erosion control product, a smooth surface, and an HECP, you want a roughened surface. Here we have an example of installation rates of products. Typical application rates on low end go at a minimum of 2,000 pounds per acre. And as you can see there, that leaves about a 20% open area, 80% coverage, 20% open. And that's probably for flat areas or arid areas. That's what you'll want to keep at a minimum of 2,000 pounds. Once you start getting into sloped areas and a little bit more higher rain events, 3,000 pounds per acre is recommended. 3,000 pounds will typically give you 100% coverage. You should see very little to no soil after an application of 3,000 pounds of hydromulch applied. And then typically when we get into the higher performing products, they'll call for 3,500 pounds of product per acre, up to 4,000 pounds per acre. Typically, you'll never see anything more than 4,000 or 4,500 pounds. That's in very extreme conditions and for very steep slopes. But that kind of gives you a visual of what you would be seeing out on an application. Effectiveness of hydroseeding largely depends on selecting the appropriate HECP and seed mixture for each specific application. It's not a one-size-fit-all. Rather, it's about tailoring the selection to unique requirements of the site that site presents. So, some of these factors that come into play are soil type. I jumped ahead of a slide here, but don't disregard that. But soil type and soil quality, climate and season, what kind of rainfalls you're going to be encountering in the next 3 to 6 months, project objectives of what you're trying to achieve, what kind of slope and drainage you have on your project. Obviously, regulatory requirements are going to mandate what kind of application you might use. And then also about maintenance requirements. Is it something you're going to walk away from and never come back to, and you might want to install at a higher level? Or if it's near society, they may be able to come back and touch things up. So all of these are kind of things to consider. So I did jump ahead here, but give me 1 second. So installation applications, there's typically 2 ways out of a hydroseeder that product's installed. And on the top photo here, you see the hydroseeder, and that's called a tower application. So this is for long distances application, and typically on freeways, they'll stay on the machine, spray long distances up to steep slopes. When you get into more intricate applications around vegetation or around lake and waterways, they'll use a hose application. So this is a little slower and more labor-intensive application of dragging a hose around, but it's more precise. And here on the right, we'll talk about, like we did, applications, rates of application. On the top is a proper application. On the bottom, you'll see what's called a shadowing effect. And hydromulches, when you only spray from one direction, because of that rough and slope, you'll see what's called a shadowing effect. So this was sprayed from left to right, and it's covering the slope on the left-hand side, but that caveat on the bottom is kind of exposed, and that can be susceptible to erosion. So it's often suggested to spray from both directions to get proper coverage. So at the ECTC, we kind of categorize, like I talked about earlier, into 5 criterias of products. Again, 1 being ultra short term, quick vegetative growth, flat areas where you're not going to be, it's not highly susceptible to erosion, and then up to type 5, and those are going to be for very steep slopes and extreme conditions. So we have this chart in our toolbox on ECTC, where you can kind of select products that are fit each category. And these have performance standards of what kind of slope gradient is you're encountering for what products you're going to suggest, the maximum uninterrupted slope, and oftentimes interrupted slopes are made with a water bar or a sediment retention device or a wattle. And then the C factor, we test products at these labs to see what kind of cover they give and what kind of what kind of erosion control effectiveness a product should expect from a hydraulically erosion control product. I'm going to quickly wrap this up, but one of the other categories we have for HECPs is replacing the typically wood component of a spray product with a compost or a peat moss or a biochar. And these are called hydraulic biotic soil amendments. And these are typically called for when you have poor soil conditions, sandy areas that have no nutrient value. That is when you might want to call in for an HBSA. Again, these are nutrient-rich hydraulic mulches that give a great topsoil alternative that can get vegetation to grow, but also as these products break down and feed the poor substrate soil to give nutrient value for long-term vegetative success. So with that, I'm going to wrap up the HECP and turn it over to Keith Potter. Thanks.
Thank you, Brian, and thanks everyone for attending. Wanted to take a few minutes and talk with you briefly about sediment control products. We won't have time to go into a lot of depth, but hopefully can share some things that might make you think differently about how you manage sediment control. Like erosion control, sediment control devices can be produced from many different types of materials. We'll touch on some of those, but the point of that is, that practice makes it obvious that they're going to perform differently in different applications. Many of the opportunities that I see with sediment control devices are to better match your sediment control devices with your specific project, and also to integrate your sediment control products with your erosion control products. Mike and Brian, they've all mentioned, different applications where you need, a sediment control device that works in conjunction with your erosion control method. The one Mike mentioned was, installing a TRM in a channel. When you're using a TRM, you may not need as robust a check dams as you would if you were using a, road erosion control product or an HECP. So just something to keep in mind. When we talk about sediment control, we're specifically talking about products that are either going to prevent sediment-laden water from leaving your site or are going to reduce the sediment movement on your site. So there's 6 applications listed here. I can group those into 3, which is how I'll kind of talk about them. One is your perimeter controls, which is the one that most people think about. That's where you can incorporate some dewatering and overflow devices that I want to hit on. The other is slopes and channels, or ditch checks, commonly referred to. And then finally is inlet protection, and that's where you have a stormwater conveyance system, and you've got to prevent sediment loss through that mechanism. I mentioned the different components. So SRDs are usually some type of fiber matrix. That can be organic, straw, coconut, wood, or even synthetic materials such as polypropylene. Typically the matrix is enclosed in some kind of a netting, which gives the SRD the structure. And again, that's where your project and the method of erosion control come in, because those site conditions and the desired lifespan of the project can dictate what you choose. So, for example, a biodegradable product might be fine if you're going to be in an area where you can establish vegetation quickly. But if you're in an area where you're not going to be able to establish vegetation, you may need a more durable product. Perimeter control, again, I'll just briefly touch on it. The biggest challenge I see here is that oftentimes the volume of water that you're going to generate once you remove the vegetation from that site is underestimated. And I'll refer you to the IECA design guide for guidance on designing sediment barriers. But the main takeaway from that is, number one, you really need to design to only impound 12 to 18 inches of water. A lot of failures occur because more than 18 inches of water is impounded and you get it knocked down or undermined. And the other one is because of that same concept, you need to think about how you're going to incorporate overflow outlets into your design. So again, just something to keep in mind. As far as different products, there's everything from sediment retention fiber rolls, which are typically, some kind of a natural matrix, to high strength, multi-flow silt fences that are stronger and more durable. And there's even, biodegradable silt fence products out there now that, again, depending upon the erosion control method you choose, may be a really nice solution to your challenge. Just a couple of reminders about, the need for volume and velocity control. So this is some examples of wire back silt fence. Again, proper installation requires that, you make sure you leave some space in between those double rows of silt fence so you have impoundment volume. And you also that you tie back into the slopes and use J hooks so that you're taking full advantage of that effective height and controlling the velocity better. So again, all addressed in the ICA design guide. Couple thing on slopes. The biggest issue here is, again, you're trying to increase your time of concentration so that all that water is not getting to your perimeter at the same time. And again, utilizing the erosion control method that you choose, You can see here, on the top right, those are fiber rolls on a slope that's, there to slow the water down so that you don't have increased erosion going down to the perimeter. The one in the middle is showing a water bar and making sure that you've got some type of in treatment at the end of your water bar on a right of way. And then finally, you can see the wattle fence on the bottom right on that nicely vegetated slope, giving you that velocity control so you can get that vegetation established. More examples in the interest of time. I'll skip this slide and move on to installation. As everybody's talked about, installation is critical, and there are installation guides in the IECA site. In the ECTC site, as well as some guidance on IECA that you can see there. The channels and ditch checks is another area that a lot of speakers have mentioned. Again, probably the most challenging place to get vegetation established when you have concentrated flow going down a channel. And more we hear that rock check dams are not always the ultimate solution. There's ways that you can use sediment retention fiber rolls as well as geotextile products to give you that velocity control that you need to get vegetation established that don't have nearly the installation and maintenance challenges of rock checks. The inlet protection is a little bit of a different beast. There's three categories that I see, above grade, below grade, and curb inlets. And I won't go into any detail on any of these. The main thing I wanted to leave you with is you really need to think about where that runoff is going to go. Because these are catch basins, you're going to get concentrated flow. That's how the site is graded. And so you need to really think about, if you're putting up something that's very rigid and has no flow rate, where are you going to divert that water to, and how are you going to manage that diverted water? The next slide is talking about the dewatering and overflow outlets. Again, this is an old concept that has gotten some attention recently, especially in the IECA design guide, but it really points out the need to look at different options. And there's 4 options demonstrated here: the dewatering board, rock and wire, two-stage silt fence, and a manufactured overflow outlet that will all allow you to handle larger volumes and peak flows, especially on big drainage areas where you're ultimately going to be dependent upon basins, but it takes time to get those basins in and get them stabilized. In wrapping up, sediment control devices again come in many different forms and fashions, made out of a lot of different materials. There's straw, there's Excelsior, there's coir, compost, biodegradable things like the wattle fence. Again, just encourage you to think about how you're going to match these up with your specific project and with your, I lost control here. Oh, there it is. With your specific erosion control solution. Specifications, there are specifications in ECTC for sediment retention fiber rolls, and we continue to work on specifications for other types of products. We've mentioned our relationship with both the Texas Transportation Institute and TRI in helping with those tests and helping with those specification developments. And finally, I wanted to mention polymers and flocculants. Most of the products that we've talked about are dealing with, trapping sediment, total suspended solids. Turbidity is a little bit of a different animal, but equally as important. And using a polyacrylamide or some type of chemical to bind to those particles and remove the turbidity from the water is another area that you need to think about when you're designing your sediment control projects. So with that, I will turn it back over to Mike, and appreciate everybody attending.
Yeah, so with all of these products that we've talked about, anchoring is definitely something that has to be done with just about every single one. There are a few that may, be self-weighted that don't need anchoring, but almost everyone does. We've divided anchors into 2 separate things. For sake of definition, we have fasteners, which are going to be considered temporary products, and we have anchors, which are permanent or longer lasting. So like your sod staples, your biodegradable staples, your wood stakes, those are all going to be fasteners or temporary. And then you have your bigger anchors like your twist pins or your earth anchors that are going to be considered permanent anchors because they're actually galvanized and made to last a longer period of time than just a year or two. So again, they're used everywhere. If you are using a biodegradable blanket or product, you're probably going to want to use a biodegradable stake as well. So there's wood stakes and there's also biodegradable plastic stakes. So they're made out of like cornstarch or potato starches that will slowly degrade over time. There are biodegradable options for your staking. And then, of course, you have your permanent ones. So, this one chart at the bottom kind of shows you the difference of pull-out strengths of anchors. And typically a temporary product, it's a sod staple is going to be more than enough to hold that in place while the vegetation is establishing. But you may need to use something else, especially on like a higher safety factor project. If that vegetation doesn't establish right away, you may want to use anchors to hold that in place to make sure that you don't lose your product or the site before that vegetation establishes, which is when you would use a hex pin, which is it's like a drill. It drills right into the ground and you get better pullout strength. There's different ones for different soils. And then, of course, there's other options as well. Earth percussion anchors are also an option. These are going to be used for soil stabilization. Going to give you, pullout strengths up to 5,000 pounds. Definitely specific applications for those. We do have a detailed guide for how each of these should be used on the website. So if you have more questions, go there or contact one of us. And here is our information. I know it was kind of a big whirlwind of information, but you can, of course, find stuff on our website. Here's our email address that you can email any specific questions to, and we will be sure to answer them. I know there were some questions that came up in the chat. I think we've answered most of them. The one I saw we didn't answer, someone asked about TRMs and transition mats. Do they break down? Usually no. It depends on the product. There are different, of course, different products, but they're usually designed life between 75 and 100 years. If they're buried, they're probably UV is usually the one that's going to degrade them. So if they're not seeing any UV, they're probably not going to degrade. And now, any good quality product is going to be made with inert plastics, which won't break down. And if they do, they won't leach chemicals into the ground. So that is something to consider, though, is to make sure that you are specifying a quality product that's not going to degrade and cause an issue. We've done some studies on microplastics, and the introduction is super minimal to the order of 0.0001% out of what is being contributed by other industries. And we are, of course, continuing to work on creating other applications to make sure that doesn't happen. There was a question about animal entrapment. So the jute netting on rotor products, all the natural netting, those are made so they won't cause entrapment. Also, if you use a synthetic material like a turf reinforcement mat, as long as it's anchored down really well and you're installing application rates for those anchors, we usually don't see any entrapments with those either. I hope I answered most of your questions. I know it's time to move on to the next presentation. But again, please feel free to reach out to us, either at phone number or email address, and we'll get back to you as we can.
Well, thank you, Mike, and thank you, Brian and Craig. And what a great presentation, and really appreciate you guys speaking today. We have a place where you can upload, where they're going to upload the notes from today. So if you're interested in a copy of the presentation, it'll be on the Stormwater Awareness Week website. I just added that to the chat. Also, if you missed any of today's presentation, you can also go to the Stormwater Awareness Week website and see a recording of this. We'll probably have it up in 24 to 36 hours. It'll be available online. So, all right, well, it's 8:59. We got lots of workshops available today and this week. I hope you can attend a few of them. So thank you for attending, everyone, and we'll see you in the next workshop.
Thank you.
Thanks, everyone.